Greetings, Math 2. We are working on fully describing a graph, and I would like you to take a look at this graph. We actually have what is called a piecewise graph in this case, and for obvious reason. It is kind of pieced together a bunch of different pieces and parts. This is indeed a function, and sometimes students look at this type of graph and they say, well, no, it is breaking that vertical line test right here and right here, and that is actually not the case. It is not breaking the vertical line test because of the open circle. We see an open circle right here. That open circle means not included. So this is when I get an input of -1, the only possible output will be this 2. We do not get a possible output of -1 because of that open circle. Alrighty, and likewise over here, if I use an input of 2, I will only get an output of 5. I will not get an output down here because of that open circle. That's not part of it, okay? So this is called a piecewise graph, and let's make a little note of that here because that would be considered the shape of this graph. And the next question we ask when we are fully describing a graph is, where is this graph increasing, decreasing, or constant? And we actually, in preparing for pre-calculus, we want to make sure that you can use interval notation. And we will go more over interval notation in the future, but I'm just going to write it here, and I'm going to see if you can figure out kind of what some of these symbols mean, okay? So this red graph is increasing here, okay? The entire red graph is increasing. And if you can tell, it kind of there's an arrow there indicating that this graph goes forever and ever and ever to negative infinity in the negative direction. And then this graph will come here and it actually stops at -1, not including -1. That's very important to note. So here's how I'm going to write that. I'm going to use a parentheses and I'm going to say from negative infinity to -1. And to show that -1 is not included, I'm going to use a parentheses here. Okay, all right, so let's talk about any other locations where we are seeing an increase. And starting here on the blue graph, I see an increase occurring right here. Okay, so we also, starting at 0, we always use the x-axis when we're describing intervals, starting at 0 and then increasing all the way to 2. Okay. Now, 0 is included. It actually crosses that. So I'm going to use a bracket, and that bracket indicates that the 0 is included. Likewise, I have a closed circle here on 2, so I am going to use a bracket there. And that is my interval of increasing on our graph here. Okay, now in order to show that it is both of these, I'm going to use the union here. Okay, so the union symbol that we were talking about previously actually comes back here, okay? Okay, so let's take a look at our graph. Do we see any decreasing movement? And I see decreasing right here on my blue graph, starting here at -1 and ending here at 0, excuse me. Alrighty, so let's make a note of that. And because they are both included, I have a closed circle here, and it is actually touching here. All right, I am going to use brackets to show it's included from -1 to 0. And I'm going to use a bracket here. And I don't see any other decreasing locations on my graph. Okay, so now let's talk about do we have any constant intervals on our graph? And this right here is our constant interval right here, starting at 2, but not including 2 because of the open circle, and continuing forever to positive infinity. So let's show what that would look like, all right? From 2 and then ending at positive infinity. Now, positive infinity does not mean a plus sign in front of it, just nothing there. And I'm going to use parentheses. Infinity is always parentheses because it's a concept, it's not a number. And the 2 is not included, so I'm going to use a parentheses there. Now, the parentheses in the brackets mean something completely different and new. Please pay attention to that. We will focus on revisiting that in class. Okay, so let's talk domain and range. Okay, the domain of a graph or a function is every x value from left to right. And first thing I notice is that this little graph down here, this red graph, continues forever in the negative infinity direction. And my green line here, it continues forever in the right direction. And every spot in between is included. Okay, there's no breaks in using up the x-axis, so to speak. Okay, so my domain is actually all real numbers, and I can write that using this special all real numbers symbol. It kind of has 2 lines on it, and it's a capital R. Okay, so now let's talk range. Range is low to high. We talk about the Y values, all possible Y values. Okay, well, let's talk our Y values going downward. Okay, my graph right here again will continue on for infinity, so it goes all the way down. Okay, so we are talking like negative infinity continues on forever. Now, as we look from low to high, oh, wait a minute, it stops right here. Okay, my graph, the highest my graph is going to go is positive 5. All right, or we can think of it as it starts at 5 and it will go down forever and ever. So my Y values, and actually this range is usually, this is the easiest to see, our Y values are going to be less than or equal to 5. That is inequality notation. Starts at 5 and goes down from there, okay? Or if you want to use interval notation, like what we used up here for increasing, decreasing constant intervals, we would write that like this. Starts at negative infinity from the low, and it continues to 5. Infinity is always a parenthesis, and the 5, because it's a closed circle, right up here, that's a closed circle, it would be a bracket. Okay, so this is the range right here. Oops, excuse me, I'm getting ahead of myself. Here's our domain right here, domain, and here is our range right here in both notations. Okay, we're seeing our range in both inequality notation and in interval notation. All right, so the next question is this discrete or continuous? And even though we have a break, there is a special name for the break that we have here from the red to the blue, and then again from the blue to the green. Because we do not have individual points, we are going to call this a continuous graph, okay? Because it does, in order to pick up your pencil, you would not pick up your pencil as you're drawing, okay? Is it a function? We already talked about the fact that yes, it's a function because this little guy is not included and it passes the vertical line test. So yes, this is a function. What are the intercepts, okay? Well, let's see. We have, in this case, our x-axis has nothing touching it, so there is no x-intercept, and that is actually an important description. So we are actually going to write that down. The fact that there is no x-intercept is an important note to make. Okay, our y-intercept, we see that right here, is 0, the ordered pair 0, 1. Okay, now let's talk maximum and minimum. Okay, the maximum, of course, is the highest point on the graph, which I see right here. Okay, right there, that's the highest it goes, and the maximum will be 5. And the minimum of the graph, if we look at the fact that this red guy goes on forever and ever, well, it's never ever going to reach anywhere. And you cannot say like infinity, because infinity isn't a location, okay? We have to say that there is no minimum, okay? There simply isn't one. So anytime you see a graph continuing on forever in the upward direction, that means there's no maximum. Anytime you see a graph continuing forever downward, that means there is no minimum. And you always look for those arrows to help you make that decision. All right, so this is fully describing a graph and the 7 most important key features that we will be using to describe. All of the little specifics we're going to be practicing over and over and over and over. So hope this helps.